Let's take a look at the question on AP and GP. This question is on the application of mathematics in the real world context. We have here Mr. Yu on his 45th birthday, which is on 1st July 2024, purchases an annuity plan, which called Youth Retired, for a principal sum of X dollars. And this plan will actually be divided into two phases. The phase 1 says that it pays a compound interest at the end of each year at a rate of 3% until he turns 65. And the total sum of the end of phase 1 is called the accumulated sum. That means to say he will be putting in a lump sum at the start of this period, and he will just let the compound interest work its magic until at the end of like 20 years, he will be able to get a larger sum. And this is called the accumulated sum. For phase 2, right, upon turning 65 years old, he will receive a money payout of Y dollars on the first of each month, starting, which is from the accumulated sum, and the amount remaining in the plan continues to draw interest of 0.2%, which is being credited on the last day of each month. Right, we need to be a bit careful. For phase 1, right, we're talking about the interest being credited at the end of a year. And for phase 2, the interest, right, which is a smaller amount of interest, is credited at the end of each month. For the first part of the question, it says write down an expression for the accumulated sum at the end of phase 1, giving your answer to find SF. I suppose that the accumulated sum actually is stretched through a total of 20 years. And for 1 year, since the interest is being given is 3%, at the end of first year, actually will just be like a 1.03 multiplied by X. And 1.3 because it's the principal plus the additional interest. And since, right, it will be actually being credited 3% every single year over 20 years, the amount should be we will be 1.03 to the power of 20x. And this we can just evaluate this. I will get a value of 1.8061x. For part 2 of the question, it says that show that the amount remaining in the plan at the end of F month, phase 2, after interest has been credited, is given by this particular expression here. Usually when we are dealing with this type of question, it's highly recommended you just draw a table with probably 2 columns. I think it will be much more clearer. In this case, we can write down, firstly, we have the month here. And here we can write down the amount of money remaining at the end of the month. Alright, actually it matters whether the question mentioned beginning of the month or end of the month, because beginning of the month the interest had not been credited yet. At the end of the month, the interest has been credited. So there's a big difference between these two. So in this question, we are talking about remaining at the end of the month. Right, so let's say we are talking about the first month here. We can just kind of imagine that the original start before any withdrawal is this amount here. It's 1.8061x. And he will be receiving a Y dollar, so therefore minus a Y. And that is the beginning of the month. And you can imagine you fast forward until the end of the month, what happened? This amount will have a interest of 0.2%, which is multiplied by 1.002. And I can just simplify a bit. I get 1.8061, 1.002x minus y, 1.002. Alright, we try not to simplify too much here because, right, if you will be simplifying too much, somehow, right, you will destroy the pattern which you're supposed to have there. Usually, our aim is to identify a certain pattern after writing out the first few terms. So we try not to simplify too much. And now, just imagine at the start of the second month, what happened to this expression? We will withdraw another Y dollars. Therefore, I will withdraw another Y dollar. This is the start of the month. And imagine that what happened if we fast forward to the end of the year, I will multiply this entire thing by another 1.002. And I will just multiply this 1.002 inside here. get 1.061, 1.002 square x minus y, 1.002 square minus y, 1.002. And usually by here I can already kind of identify the pattern already. And if we want to be safe, we can just write one more term here. We can just do the same minus this whole expression by y. Then I will multiply 1.002 at the end of the month, which will give me a final result of like 1.8061, 1.002 to the power of 3x minus y 1.002 cube minus y 1.002 square minus y 1.002. I can kind of like identify a pattern and imagine I can extrapolate it into like a nth month now. And what happens if it's an nth month? Again, I will be able to get something like this, 1.8061, 1.002 to the power of n, because this is 3, 3, 2, 2. Therefore, if it's an n, it will be an n here, minus y 1.002, n minus y 1.002, n minus 1 minus y 1.002, n minus 2, and it will keep going until we have y 1.002, and there will be a total of n terms here. Alright, my suggestion for this particular pattern here, I will usually try to extract out those common factors, and I can observe that actually the power is decreasing, and usually it's harder to analyze if the power is decreasing, right? Instead, I can think of this like I will reverse the whole sequence. That means I'll treat this as the first term, right? This as the second term, this will be the last term. I will be able to end up with something like this, 1.002, and take out the y, which is the common factor among all these terms, reverse the sequence, I get 1.002 plus 1.002 square plus 1.002 cube, all the way until 1.002 to the power of n. Alright, all we need to do is making use of the sum of GP. Sum of GP, the formula we have is Sn equal to A, Rn minus 1 over R minus 1. There's another version which is this. In this case, I prefer to use this so that because the value of R is actually more than 1. Actually, it doesn't matter which one we will be using, but I'll just be using the first one. I can just sub in the values into this formula here. I will have my first term to be 1.002. Common ratio will be 1.002. In this case, there will be n terms, n minus 1 over 1.002 minus 1. And I can just do the final simplification here. I get 1.8061, 1.002 to the power n x minus 501, 1.002, n minus 1 y, which is the result that I need to show. Okay, let's continue with part 3 of our question. I have replicated the expression that I've shown in part 2 here for our easy reference. And for part 3, it says that Mr. Yu wishes to receive $1,000 a month in phase 2 for at least 10 years. That means to say he wants to receive $1,000, which is our y. For 10 years, basically means that n should be 120 months. And what is the minimum principal sum he will need? That means it's the initial lump sum that he put in right at the start for the plan. I think what we require is to solve for this x. And I think since we have the value of n given to us and the y, I think we should have no issue solving for x. I can just sub in the value of my n, which is 120, x minus 501, 1.002, 120 minus 1, 1000, and I will just set it to be greater or equal to 0. I will just re-express my x to become greater or equal to 501, 1.00, 2 to the power 120 minus 1, 1000, divided by 1.8061, 1.002, 120. I think I can just key in this expression into our GC and should be able to solve for the value of x. Okay, let's go to our GC, which I've already keyed in here. I will be able to get a value of x to be, x will just be equal to 59136 for this case to the nearest dollar. Okay, let's continue with the next part of the question. And now Mr. Yu decides to put in a principal sum of 200,000. That means to say x now is 200,000. If he chooses to receive $2,000 monthly in phase 2, in which month will he receive the last payout of $2,000? Okay, let me just write it here, part 4. All right, for this same expression, right, I will be subbing in y to be $2,000 now, and now x is given to us to be 200,000. Subbing in, I'll get a 1.8061, 1.002, and x is 200,000, and 501, 1.002, and minus 1, and this y is equal to 2,000, and I want it again to be greater or equal to 0. I think for this particular expression, it will be easier if I can just use our GC to solve this. Okay, let's go to y. Okay, so for this here, I have already keyed the whole expression here. And since the unknown that I'm trying to find is like an integer, it will be slightly easier if I use the table instead of a graph. I can just go to second graph here. Okay, in this case, right, I have to make sure that the value, right, will be close to 0. Okay, I can go to second window to trigger the table set. Maybe I can just try around 220, second table. All right, so now we can see that as we go down, right, I think the last month that he will be able to receive the payout is on the month 223rd month, right? Because by the next 224th month, it already turned into negative already. So this is not what I want. So I know the answer will be 223 months. And we got to draw a table for ourselves to present the answer. So therefore, I can just draw a table here. Okay, this is the end. And I will like to write down the value and the term before the one that I want and the one after it. So therefore, I will just write a 222. 223 is the one that I want, and 2 is 224. The value here is equal to 3511.4. This is 1514.4. This is minus 486.6. And this will be the entire expression, which is like 1.8061, 1.002, and 200,000 minus, okay, 501, 1.002, and minus 1, 2,000. Okay, and this will be the one that I want. And therefore, n will just be 223. And we can kind of like use our calculator, just use 223 divided by 12 to get a feel how many years is it. And this happened to be a total of 18 years. And we can just calculate the number of months left. It will just be 7 months left. And by using these values, right, we can actually come up with the final month and the year in which you will receive the payout, which managed to be work out to be January 2063. Okay, now let's look at the last part of this question. It says that an alternative plan is such that phase 1 remains the same, but phase 2 provides a payout of 1,500 in the first month, and the subsequent month increase by 100 each month. So now the so-called Y is varying already. However, the remaining amount in the sum doesn't earn any interest anymore. So for this alternative plan, if he decided to take out, calculate the highest payout he received and determine the month that he received it. Okay. Okay, first, all right, if he wanted to have a payout of a total of 20 years, right? Because 20 years, right? After 20 years, I want to see how much he will have the accumulated sum, which is happen to be in 20 years, the accumulated sum that he will be having is 1.03 to the power 20, 200,000, which work out to become equal to 36122.25. So this is the pool of money that he can withdraw from. Okay, and total amount, right, that he will be withdrawing, right? Withdraw basically will just be equal to in n months. It will just be equal to n over 2 to 1,500 plus n minus 1, 100. Okay, what we have here, right, is actually we are doing the sum of a AP, which is given to n over 2, 2a plus n minus 1d. Right, in this case, the n is an unknown. The first term, the first month that he withdraw is $1,500, stated in the question. All right, and this d, right, is the common difference, which is increasing 100 per month. So therefore, I will have this result. Right, I want to see using this result, right, compare with this amount in the pool, how many months I can have before this one is completely depleted. So again, I think the best way of doing this is to use our GC. Okay, I've already keyed in the equation already. Let me just uncheck the first one. Okay, this is the second equation that I need. Again, the unknown that I'm trying to find is like an integer, so I'm going to make use of our table. All right, second graph. Okay, and I'm going to change the window settings to perhaps around, say, like 70. Okay, second graph. And, okay. So it's somewhere nearby the total amount that I have. It's like 361K. 361K. Okay. So I can see actually 71 is the answer that I want, right? Because if it's 72, right, it will be exceeding the amount I have already. So therefore, I can see that n should be equal to 71. Right? Then we can conclude that the highest payout will just simply be equal to A plus n minus 1d for a general term for AP, because I want to find the particular month what is the amount that he will be withdrawing. I'm using actually this UN equal to A plus n minus 1d. This is the general term for AP. First term will just be 1,500 and n will just be 71 from the calculator, minus 1, and common difference is 100, which will give me a total of $8,500. And this is the month that he will be withdrawing, is the 71st month. I don't think for this particular question, I need to really state which year and which month that he will be withdrawing. I think the 71st month should be sufficient already.